Hey, fourth grade, before you watch the next part of this video, I just want to point out a few things. You do need this stock up poster. It's double-sided, came home on the bus, for your lesson today, 712. Pay attention to the details on this poster because in your word problems, it asks you to add and subtract decimals, which I'll go through here in a second. But if you look very closely, a lot of these items have different prices. For example, this electrical cord is $3.25. But if you buy 5 or more of them, it might be kind of blurry, you get them for $2.79. So if the word problem has 5 or more electrical cords in it, you better use the price that it says for 5 or more. Same thing applies for maybe like this light bulb. I'll go to it. It says light bulbs, a 4-pack cost $109. But if you decide to buy 5 or more packs, 5, 6, 7 packs, 8 packs, well then you get a deal and it's only 88 cents per pack. So when you look through this, you make sure you pay attention to those types of details and the problems will become a little bit easier for you. Now here's my lesson on how to add and subtract decimals. Hey, fourth grade, I'm here today to help you with lesson 712. This is a newer concept on how to add and subtract decimals. And if I have time, I might even teach you how to multiply decimals quickly and efficiently, so you can do that as well. But before I jump into how to add and subtract decimals, I am going to review with you some of the place values because I'm going to be saying a lot of place value throughout this video. And if you don't know which place value I'm talking about, it might get confusing. So I'm going to start with the decimal. A decimal is something that separates everything that is whole from everything that is part of a whole, like a fraction. I'll give you an example. If I had 1 whole apple, that would be in the ones place value. If I had 11 whole apples, that would be 1/10 and 1/1. You are pretty familiar with every place value to the left of the decimal, but to the right, the fractions or parts of the whole, that's one thing I think we need a little review on, okay? The first place value after the decimal are things that are broken up into 10 equal pieces, the tenths place value. Okay, now keep in mind as I do this, this would say 11 and, so you say and at the decimal, 1/10. That's like 11 whole apples, and then if I were to chop another apple up into 10 pieces and take just one of the pieces, it's 11 whole apples and 1/10 of the next apple. Each place value is to the left is 10 times greater than the place value to the right. It takes 10 tenths to make 1 whole. It takes 10 ones to make 1/10. It takes 10 tens to make 100. It takes 10 hundreds to make 1,000. And it goes forever and ever and ever and ever. It also goes forever the other way too, though. The next place value, I'm only going to do 3 behind the decimal. It takes 10 blank to make 1/10. It takes 10 hundredths to make 1/10. Excuse my handwriting vertically, it can get challenging, but so it takes 10 hundredths to make 1/10. So, and if that's getting a little confusing for you, just remember the order of the place value. So to the right of the decimal, the first one is the tenths, then the hundredths, and then the thousandths. Kind of sloppy, but the thousandths. And it takes 10 thousandths to make a hundredth. It's like chopping an apple. I have 11 whole apples, and if I had only 1,000th of the next apple, that'd be like taking an apple and chopping it into 1,000 pieces and only having one of those pieces. Okay, now if you need to take time to pause the video and memorize these place values, do it, because I'm going to be saying them quite frequently when I'm talking about how to add and subtract decimals. Okay, now I'm going to jump into some example problems on how to add and subtract decimals. This next piece is going to be the easiest type of adding and subtracting decimals. The most important thing you need to remember is lining up the decimal, but I'll talk about that in 1 second. Let's just pretend I had 5 whole apples, and we're just going to be sticking with the apple theme today. 5 whole apples and 2/10 of another apple. Okay, I don't know what happened to the other 8/10. Maybe we gave them to a friend. And then somebody else gave me some of theirs, and it was 2 whole apples and 4/10 of the next apple. In fact, I'm going to make it a little bit more challenging so we can work with carrying and everything else. I'm going to say, and then 9/10 of the next apple. This is what I would consider an easier addition problem with decimals because they both end in the tenths. 5 wholes, 2/10 of the next. 2 wholes, 2/10 of the next. So this one's rounding down to 5 apples about. This one, if I were to round it to the nearest whole apple, it'd be about 3 apples. Let's add these up. I never ever, when I add and subtract decimals, do them horizontally. I always line them up vertically. So I'm going to take this and swing it under. Most importantly, like I said earlier, is lining up the decimal. This is the same problem written vertically. Notice how I have my decimals stacked right on top of each other. I'm going to drop the decimals straight down for my answer. At this point, it's as easy as just adding. It's just like we would do a whole number, but it's just with decimals now. 9 plus 2 gives me 11. Just like adding normally, I carry the 1 to the next place value to the left. Just so happens to be the ones, or the wholes, or the first ones in the wholes. Now I add 5, 2, and 1, which makes 8. 8.1. And I'm all done. It was as simple as just lining up the decimals. And like I said, that's an easier addition problem for decimals because they both end in the tenths place value. The most common mistake kids will make when they add and subtract decimals is not lining something up due to them not ending in the same place value. I'll give you an example of that type of problem. So this would be a little bit more challenging problem. I had $6.23. And my friend gave me 5 more whole dollars and 7/10 of another dollar. Okay, all right. And you're so conditioned, because I've taught you so many times, line up that last number to go like this. And I want you to pause the video and tell me, or whisper to maybe a parent or to a brother or sister, what is Mr. Shorter doing wrong? Okay, so I'm going to line up 7.5. Okay, now I'll get rid of that like he told me to. 7 and 3 make 10, carry the 1, 2 and 5 and 1 make 8, 6 by itself, 6.80. Do you notice what went wrong? Go ahead and pause the video and maybe tell somebody if you're sitting next to somebody, or you can even whisper it to your dog if you want to, but go ahead and pause the video now. If you've paused the video and now you're back with me, you are hopefully saying to somebody that I did not line up the decimals. That was my big mistake. So if I go right here, so this is the wrong version, I'll just cross it out real quick. 6.23, and I'm adding 5.7. Well, my first step is to line the decimals up, put that decimal right under that one, and now write the number as is. Make sure the ones lines up with the ones, the 6 and the 5 are whole ones. And then the 7 is a 10th, and the 2 is in the 10th spot. That's how they should be lined up. But you might be saying to yourself, well, Mr. Shorter, what do I add to 3 here? Remember, we've talked many times, and this might be a good review for some of you, that you can add zeros onto any decimal and it stays the same value. I'll do an example down here using the same decimal, 5 and 7/10. We've talked about many times that as a fraction, 70 hundredths, 5 and 70 hundredths, is the same thing. It's the same as 5 and 700 thousandths. It's the same thing as 5 and 7,000 10,000ths. It's the same thing as 5 and 70,000 hundred thousandths. And it would go on forever being equivalent or like we like to say, equivalent fractions. That being said, I can add a 0 to hold my place value. Now it looks a lot easier to add, and I'm going to do what Mr. Shorter said right away. Line up the decimal, drop it straight down for the answer, and now just go about it as if I were adding any other whole number. 0 and 3 make 3. 2 and 7 make 9. 5 and 6 make 11. Carry the 1 into the tens place value, and you have 11 and 93 hundredths. And when I think about that number, it's 11 wholes and 93 out of 100 of the next whole. So I haven't done any subtraction. I'm going to do one example of a subtraction problem before I move on. This one can be confusing to the eye because when I subtract decimals, sometimes they look really big. For example, 6.2, and I'm going to get rid of 3 and 13 hundredths. Looks a little confusing because this number almost looks bigger, but it's not a comma, it's a decimal. This is a lot smaller number than this. This is 6 wholes, whereas this is 3 wholes. So my answer, if I think about some estimation as I do this, should come out close to 3. Now, line up the decimal, do it vertically, and put in the zeros to hold your place value. Get rid of it, line my decimal up. I'm taking this and I'm putting it down here. 3, 1, 3. Notice, once again, my decimals are in line. I'm thinking, what do I put right here? Same concept. 6 and 2/10 is the same as 6 and 20 hundredths. I can put a 0 there to hold it, and it doesn't change the value at all, okay? So now, once again, it's a subtraction problem, so I got to do bigger bottom, better borrow, do all of the borrowing first. That's something we say in my class. I don't know if I've said it with all the 4th grade classes, but I'm going to borrow in order to help out this 0. 2 becomes a 1. Borrow 1/10, it gives you 10 ones. 10 minus 3 leaves me with 7. 1 minus 1 leaves me with 0. 6 minus 3, 3. 3 and 7 hundredths. I'll make that decimal a little bigger so you can see it. 3 and 7 hundredths, which is awfully close to 3. It's just 7 hundredths more, like 3 whole apples, and 7 itty-bitty pieces if I chop the apple up into 100 pieces. So adding and subtracting decimals is not that complicated if you line up the decimal and you add zeros to hold place value. Just don't rush yourself, and you should be able to do that quite easily.